Part 2, since we ran out of time. This one is a little bit lengthier, but the only reason why it was longer is because I was showing you why we restrict the functions. I was drawing the graphs, and I was using a different color to show you that. So yeah, it takes a little time, but I think it's important. I think it's good to know why these things are, because honestly, when I learned it in college, they just said, these are the domain restrictions, and that was it. They didn't draw any graphs, nothing like that, so kind of had to know what was going on yourself. But anyway, part B, so we have tangent of theta equals -3/5, and we want to know what theta is. What is the angle? And we have this little guy right here. It's kind of like a restriction in a way. They're telling me that the angle is between pi/2 and pi. So we could see here that this would be quadrant 2 is what we're looking at here. Okay? Alrighty. So, how do we do this? Well, let's go back to what we did yesterday. Okay? So, theta would be the inverse of tangent, which is -3/5. Okay. And on your calculator, why not? Let's practice it. And we're going to keep it in radians. So if you want to look, I forget where we ended on. I think it was degree mode. Okay, so let's put it back in radians. And I will say, when you guys take your next test, or even the final, please make sure you look at your modes each time. It's very easy to miss. All right, so mine's already in radians. So let's do second tangent, -3/5. Okay. And it tells me in the instructions 4 decimal places, so we're going to go 4 decimal places. And we get -0.5404 radians. Okay? Now, typically we'd be done, but they do give me this guy over here. They want the angle to be in quadrant 2. And if you remember from yesterday, tangent, we restricted it from quadrant 4 and 1. Okay, -pi/2 and pi/2. So how do I get to quadrant 3 with that? Okay, well, we're going to find the reference angles, right? So let me just go ahead and draw this. Okay, so we're over here. That's where we're at. So this was 5404 radians. So to get over here, okay, what I can do is find the reference angle that puts me in this quadrant. So I'm going to be over here. That's where I want to be. So let's find this reference angle to figure it out. Now, the good news is my reference angle is just the positive end of this guy, so that was easy. The example beforehand, the degree measurement was all the way in second quadrant, so we kind of lucked out. Both of these were in second quadrant. Didn't plan it that way, but oh well. So my reference angle over here would be 0.5404. This is pi. So to figure out what this entire angle is, I could take pi minus the 0.5404. So let's do that. So again, this is not the angle we want necessarily to put in quadrant 2. I hate using theta twice. Oh well. Yeah, well, I could use prime. We okay with prime? Let's just do prime. So I'm going to do pi minus 0.5404. So the angle we're looking at, it's going to be 2.6012. So 4 decimal places. Okay. All right. So what this example was doing, we know that the restrictions we have on inverses puts us in certain quadrants. So to figure out how to go in a different quadrant, we got to find a reference angle to get us to that point. That's all it is. All right, let's talk about composition. Okay. Going back to algebra. So if you remember inverses in algebra with functions, okay? If I were to do some composition with them, so if you remember, it's not an O there, that's composition. So f of inverse of f of x. That's a mouthful to say. If I were to expand this, okay, This is me just expanding it. So it tells me whatever x is, plug into the inverse, and then whatever that is, plug it into f itself, okay? Well, because these are inverses, they pretty much undo each other. All the operations, we don't know what the equation is, but all the equation stuff cancels out. We just get what we plugged into it, so we just get x for that guy, okay? And the same is true if I flip these. That's why inverses are so cool. It doesn't matter what order you apply the inverse. I'm still going to get what I inputted into the function. So we did that back in algebra, okay? I'm going to do the same thing with trig. The only difference is I got to make sure I keep in mind like all the restrictions on my domains, okay? So let me go ahead and put a little table here. Composing trig functions and their inverses. Okay. Now I'm going to go ahead and do it sine, cosine, tangent. I'll show what those look like, and I'll put the restriction next to them. That way you don't have to like flip back in your notes to see what they were at the beginning. So if I take the sine of the inverse of sine of some value x, I get x, because again, they undo each other. But that only works if we keep in mind the restriction we applied from before. As long as x is between those two values, we can do that, okay? We can do the same thing, I'll put here for radians, okay? So if you're looking at radian measurement, okay, between negative pi over 2 and pi over 2. Okay, next, let's look at cosine. So cosine of the inverse of cosine of some value x just gives me x. Okay, and that's when x is between 1 and negative 1. I'm looking at the radian measurement, and we know it's between, oops, it's an x, 0 and pi. Okay. And then lastly, tangent of the inverse of tangent of some angle is just the angle back. Okay. And for tangent, remember, all real numbers for that guy, we don't have to worry. And then a radian measure for, oops, that's a 2. Get a little sloppy. Negative pi over 2 and pi over 2. Bless you. Okay. So again, these only work if you're within the restrictions that are there. Oh wait, those are y's. That was looking weird to me. I'm so used to writing x's. My apology. Yeah, those are y values. Okay, let's try some out. So find the exact values. Okay, look at the first one. Okay, we have 0. Now, again, these cancel each other out. We should just get 0, but is 0 within my values here? Absolutely, right? So this whole thing, I'll put underneath it. Because it's within our values, it's just 0. That's it. Simple enough. Now, if you want, you could do this a little differently, okay? The other way you can do this is you could say, well, I know that the inverse of sine of 0 is 0, and if I substitute it in there, sine of 0 gives me 0, so the whole thing's 0. So you could break it apart if you want, like order of operations, okay? If you want to evaluate what's here first, and then whatever this is, take sine of that value, you can do that, okay? But if you know these guys, if you know what the restrictions are, you can get to that answer a little bit sooner. Does that make sense? Let's look at B. So inverse of cosine of cosine. So all I did is I just switched the positions. Okay. So I'm going to go ahead and look at what cosine of 7 pi over 6 is first, and then take the inverse of cosine. Okay. So I'm going to take this approach here. I'm going to go kind of like order of operations with this guy. So let's look at what this is. So cosine, inverse of cosine of 7 pi over 6 is equal to inverse of cosine. Now, 7 pi over 6. Let's think about where that is. So that would be in quadrant 3. The reference angle is pi over 6, and cosine at pi over 6 is square root of 3 over 2. Because we're in quadrant 3, it is negatives. Okay. I'm out of space, I'll put underneath it. So now we got to figure out what the inverse of this guy is. Well, think about what cosine is. Cosine is between its output values are 0 and pi. Okay. So with 0 and pi in place, this must be 5 pi over 6. And I'll put here, we have to be in quadrant 2 for that to work. Okay. Now, these are angles that are exact. Okay, so it makes it easier to actually figure this out. If the angles were not, like those special ones we have in the unit circle, okay, what do we do next? So let's look at some of those. Okay, so I'll put it over here. So again, find the exact value of, I'll put it up here, sine of the inverse of tangent, negative 2/5. Okay. And negative 2/5, that's not under unit circle, right? That's not one of our special angle values. So I'm going to have to do a little bit of work to figure out what this is doing. Now, the good news is, by hand, it's not a bad thing. But you do have a calculator. So when you're done, you can check your work quickly by typing that whole thing in and see if you get the right answer. Okay? So how do I mess with this? Well, what I'm going to do is just focus on this part first. I'm going to figure out what that is. Once I figure out what that is, then I'll take sine of that to get my final answer. Okay? So let's focus on that part. So let's let theta be negative 2/5. Now, tangent, let's think about its restrictions. So tangent is restricted from negative pi over 2 to pi over 2. So quadrant 4 and quadrant 1. Because it's negative, we must be in quadrant 4, okay? So let's put here, we are in quadrant 4, okay? So it's very critical. So today, tomorrow, as you're practicing this, try to get used to these restrictions so that you know what quadrant you're in. Okay. So we know what that is. Okay. Let's draw a triangle and see if we can't find some other measurements to figure out what sine is. So I'll do a little math drawing over here. Okay, so there we are. Okay, so we're in that quadrant. Now negative 2/5, so it's going to be, remember, it's y and x for tangent. So it's going to be 5, negative 2 is our point. I'm going to draw a nice little triangle. So this is 5, this would be negative 2. Okay. And what I'm going to do, because I want to find sine of this angle, okay, which I guess I forgot to put the angle there. I want to go ahead and find this guy, right? I want to find this length, because sine needs that length, right? It needs the hypotenuse. So I'm going to put that as r. We're used to seeing it as r anyway. I'll use the same variable. So let's go ahead and find r to find sine of theta, okay? So this would be r squared is equal to 5 squared plus negative 2 squared. So r is equal to the square root, so it'd be 25 and 4, so that's going to be 29. And that's as far as that goes. We can't simplify any further. Okay. Now that we have r, we can find sine of theta, and we're pretty much done. Okay. So let's take a look at this. I'm going to rewrite that down here. So we have sine inverse of tangent of -2/5. It's the same thing as sine of theta. Again, theta is just this whole thing that I'm putting in. And sine of theta would be -2 over square root of 29. And we do have to rationalize it, so we'll multiply top and bottom by square root of 29. And we get this as my final answer. Okay. So again, I'm swapping this whole thing out. I'm drawing a triangle to figure out some of the dimensions that are here that I need for this angle theta. I know I need the hypotenuse of this because that's what sine uses. So take this out, put theta in its place with all that information, put the triangle information next to it, and you're good to go. So I want a little bit more work involved when you don't have the exact values there. But again, you can check with your calculator. Now this isn't the decimal version, but if you want to plug that in, get your decimal version, and then type this in your calculator and compare values, you can do that. Okay, questions? All right, let's do one more. This is kind of, for those of you who are going to take calc, this example kind of echoes calc in a way. So evaluate the expression tangent of the inverse of cosine emphasis that x has to be positive. It's weird, actually, looking at this problem, getting flashbacks to some calc stuff, specifically integration. So yeah, you'll see something similar to this. More towards the end of calc, you'll see something like this. All right, so using the same process over there, let's let theta be all this stuff. It's going to be the entire thing. Okay? Let's go ahead and draw our triangle. Let that be theta. Okay? So, looking at it, x is positive. We got to figure out, well, first we'll be in quadrant 1, right? Okay? Since x is positive here. So this is not going to have any negative y values as an output. So, my apologies. We are in quadrant 1. But it's kind of hard to draw a point because there's no numbers. This one had numbers, so it was easy to actually draw a definitive point. This one doesn't, but that's okay. We really don't need that. Cosine is the adjacent over the hypotenuse. Okay? So my adjacent's x, my hypotenuse is square root of x squared plus 16. Okay? So if I'm going to evaluate tangent of this, I need the opposite side. Okay? So let's call that a y. So what I gotta do is I gotta figure out what y is. And I can use Pythagorean theorem to do that, just like what I did over there. So let's go ahead and figure out what y is equal to. So x squared plus y squared equals square root of x squared plus 16 squared. We get x squared plus y squared equals x squared plus 16. The square root cancels out with the power. This is looking pretty good. Those are gone. We get y squared equals 16. So y must be 4. Because we're in the first quadrant, we don't have to consider negative 4, right? So we don't have to worry about a plus or minus there. Now we have all the information we need to evaluate, so let me just write everything down. So tangent of the inverse of cosine for all this stuff same thing as tangent of theta. And we know that it's opposite over hypotenuse or over adjacent, so it'd be 4 over x. So that whole thing is equal to 4 over x. This one we really can't check with a calculator because we don't have actual values. So here we just have a bunch of variables. Once they tell me what x is, then I could be a little bit more specific with what tangent of theta is going to be. Okay? But again, this is definitely a more calc-heavy problem where you would actually, here's the weird part, you would do this, and then you do more with it. So this is just coming up with what tangent of theta is equal to before you do anything else with it. All right, let's do an application problem with this, and wrap up with secant and cosecant. Then we finish. Avalanches seem to occur most often for slopes between 35 degrees and 60 degrees. The slopes at a local ski resort have an average rise of about 2,000 feet for each horizontal run. Of 2,559 feet. Is this ski resort prone to avalanches? I hope not. That'd be awful. Can you imagine skiing and then just have an avalanche hit you? Be like, yeah, I'll be back next year. 10 out of 10, 5-star. Okay. So first step, let's create a triangle. We know there's an average rise and an average run. So there's my vertical and horizontal sides of a triangle. So average rise, 2,000 feet. Horizontal run, 2,559 feet. And I want to know what angle is created with those two sides. And we're hoping that it's not in that range of 35 and 60. That would be very bad. Very bad. So, what do we do? Well, let's label the sides in proximity to the angle. So this is our opposite side. This is my adjacent side. So what trig ratio would I use for opposite and adjacent? Tangent. Yeah, so we're going to use tangent. So we're going to have here tangent of theta is equal to 2,000 over the 2,559 feet. Now to get theta by itself, we do the inverse, right? I'm going to show you, I'm going to do it. I'm going to show you. So you know how if you had 2x, you would divide by 2 to get x by itself. So how do you undo tangent? We do the inverse. So how does that look? Okay, I'm going to show you how that looks. So you would do something like this. You would apply the inverse of tangent to both sides. You do not have to show that when you're working things out. Okay? If you just want to jump to this, that's perfectly fine. Okay? Because again, these cancel out, I just get theta itself. So that's what's going on behind the scenes. I mean, when I solve these problems, I don't technically show that step, but just to show you, like, that's how you get rid of it. You got your calculators. Put it in degree mode, though. I think we're in radian mode. Okay, what's the angle?
38 degrees.
Yeah, 38 degrees. Don't go to that ski resort. Unless that's the last ski resort you ever want to go to. That'd be sad. Okay. Any questions? Yeah.
About that example on the far left board.
This one?
Yeah, where'd the inverse tangent function go? Like, why did we just...
This helped me figure out what I needed over here. That's all it did. So once I got the information I needed to find sine of it, then I just applied sine to get my final answer. Because I want sine of whatever this triangle is made of. So this is just helping me to find that triangle and finding its dimensions and both sides.
Theta isn't the value of tangent negative?
Theta is all of this. Theta is everything here. Oh, I guess I should put tangent there. I'm sorry.
Okay, because I was like, where'd the tangent? Because that could just.
Did I do that over
the
here?
other one made sense. No,
Yeah, I
the other
did.
one
I
made
did it
sense.
over here. I just forgot to write it there. I'm sorry.
Because then you could just substitute. But
Yeah, that's all we're doing. So the inverse of tangent, again, just providing me the information I need to find sine of that angle.
Okay.
That's what that's going for. Yep. Okay, let's do secant and cosecant, which ain't much. We are done.
-2 or 5 would have gained 3.
All right, secant and cosecant.
I didn't do that one or that one.
Now, at the same time, I'm not going to draw the graphs and show our restrictions. I'm just going to jump to what those restrictions are. If you want to see the graphs, it's in the textbook. But again, I'm just going to save a little bit of time than going through each one. But we know the process at least, right? If I were to graph those, we know that we have to restrict them so it passes the HL test. Okay, so this is after all that's done. So this will be, okay, so starting with what we did with the other ones. So there's the inverse of secant, okay? So this is where our x values have to be greater than or equal to 1, okay? And the restriction for the y's, 0 to pi over 2, or pi over 2 to pi, equal to pi, less than or equal to pi, okay? So that'd be secants. And the last one, cosecant. So again, absolute value of x has to be greater or equal to 1. And negative pi over 2 less than or equal to y less than 0, or 0 less than y less than or equal to pi over 2. So there are its restrictions. So again, how I got those is I just went ahead and cut off the graph to where I get most, well not most, all of my y values, my outputs. And making sure that it does pass the horizontal line test. So let's use them. Approximate each expression in radians. Round to 4 decimal places. All right, first one.
notice that if I were to flip that fraction, that square root of 3 over 2 is familiar, right? That's a special angle thing that we can work with. Cotangent, no. Okay, so in these two examples, I have one example that's going to work out nicely. I have one example where we're going to have to use a calculator to figure out some things. Okay? So that's what we're going to end up doing here. So for the first one, let's list some facts. So we know that secant of theta is 1 over cosine of theta. We're going to use that fact to simplify what this is. Okay? So then, we could say secant of theta, which is equal to 2 over square root of 3. Okay? It's the same thing as 1 over cosine of theta equals 2 over the square root of 3. So I just swapped out secant of theta for 1 over cosine. And to make it proper, to make cosine not in the denominator, cosine would equal square root of 3 over 2. So if I were to solve for cosine, I get cosine of theta is equal to square root of 3 over 2. That we can simplify. So now I want to solve for theta. So theta would be the inverse of cosine of square root of 3 over 2. Now, let's think about it. Square root of 3 over 2 for cosine. What angle gives me that? No. 30, pi over 6, right? Okay, so this is equal to pi over 6. Now to satisfy this, because your textbook does it, so like, I guess I'll do it too. 4 decimal places, so if you do plug in your calculator, which I think is a little ridiculous, but oh well. I'll make sure that we put that next to it, so 0.5236. So when you get to these guys, use the quotient or the reciprocal relationship, and then start using the inverse to solve it. Which ain't bad, it's actually pretty easy. Now, cotangent, well, kind of is easy, but we had a snap, okay? So, let me just write here. Using the same process from part A, we can evaluate, okay? So again, looking at what I did with part A, I took secant, I flipped it 1 over cosine, and then I solved for cosine, which flipped the whole ratio. So cotangent, its reciprocal is tangent, which means it would flip this guy. So what this would be tangent of 15 over negative 8. Okay? But here's the issue. With these guys, we lucked out. Cosine and secant have the same output ranges. So this works perfectly. Cotangent and tangent do not have the same range outputs. Okay, so what do I mean by that? So we can't use this because cotangent of negative over 15 is in quadrant 2. And tangent of this guy will be in quadrant 4. So that kind of sucks. So I can't do that same trick with these guys. So what do? We're going to use what we did kind of in some prior examples, okay? I'm going to draw a triangle of where this is located, find some values, and then find sine, cosine, or just some other trig value that'll also give me the same angle measurement. I'm going to just put it over here because I don't want to squeeze it down there. Here we go. So my angle's over here. This is 15. This is negative 8. So again, if I try to find tangent at the same angle, It just doesn't work, because like I said, it'd be over in this quadrant. But what I could do is this. I could find the hypotenuse, and then either use sine or cosine to find what that angle measurement is going to be for us. So let's do that, okay? So let's find the hypotenuse. I'll put that as r. So r squared is equal to 15 squared plus negative 8 squared. So r is equal to the square root of 289, which gives me 17. That's a nice number. Okay, now it's our decision, depending on what we want to do. If we do cosine, I don't have to worry about anything, because cosine kind of falls with this. Cosine would be in the second quadrant. It matches its restricted y values. If I did sine, I'd have to use reference angles. So I think cosine's a better fit for this. So my theta is going to be equal to cosine, the inverse of cosine, of negative 8 over 17. This you do have to plug in the calculator. So when you do that, you get 2.0608. Okay, so that's going to be my angle measurement for that. So this is important here. Okay, this didn't work because it was in the wrong quadrant. Okay. Any questions? That's a lot. That is a lot to handle.